Hi guys, this is Jerry from Techvangelists. It's been a long time we shared on this channel. There's been a lot of development with LLMs and AI and whatnot. So today's video is about something really cool that would say maybe it's trendy right now, but that is really cool. It's how you can chat with your database with natural language. So I've seen a lot of videos where people are talking about how to do the same, but I see that they really have to pass their tables, like chat with just a specific table. So I went ahead to make this experiment where you can chat with multiple tables at the same time. There could be joins, there could be inner joins, there could be complex queries. So let's see how this is done. I'm going to use MySQL here to do this demo. And here I have my MySQL bench. I just named this Honor World, this database called Honor World. And in the Honor World database, I have three tables called transactions, I have users, and I have wallets. And here are the data in this database. First, I went to ChatGPT and I just made a query, give me the SQL command for MySQL to create three tables, blah, 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 and put some data inside. So this is very strategic because if you need to have some sort of relationship, then you need to have the users table first because it's like the base table for all sorts of truth. And you have all the data inside before you can have the wallet table, because in the wallet table, as you can see, there is a user ID, which is the foreign key to this table, a primary key to the users table. So you need to have the users table first, and then you can have wallet and you can have transaction. For transactions as well, you can see wallet ID, which means that the wallet table needs to be created first before you can have the transactions table. So just in this order, I've created the database, and you can see that here. Just three items. In the case of transactions, you have 4 transactions. In the case of users, you have 3 users: John Doe, Jane Smith, Alice Brown. And in the case of wallets, you also have 3 wallet IDs from the 3 users, 1 to 3. So let's go back to our code and see how we can chat with this database directly through natural language. I've prepared a Jupyter Notebook file and I'll be using Ollama. Of course, you can use any LLM out there, closed source model like ChatGPT. You have to pay for the usage of the LLM responding to you. But in this case, I'm using a free and open source LLM, so I'm not paying for anything. I don't need any API key. And I've tested a few LLMs from Ollama. If you don't know what Ollama is, I'll show you what it is right now. You go to this website, it's called ollama.com, and when you get there, click on this link, models. In fact, when you get to Ollama, the landing page of Ollama, you will find something like this, and first you should download Ollama to your system, the one that corresponds to you. In my case, I'm using a MacBook, so it says available for Mac, this, and just download. Once I download this, it will give me a place to install, and then you install Ollama. That's really simple. And after installing Ollama, you should get something at the top here, and that's the sign that shows that Ollama is working. And another way to check Ollama is working is to come to localhost and do 11434. This is the default port of Ollama. If you change it, then it will be something else, but this is the default port. If you come to this, you will get this message saying Ollama is running. So if you installed it properly, then your Ollama should be running at this point. The next thing to do is to come to models, as I was saying, And the most capable model right now on Olama is the Coin 2.5 coder. And in fact, it's the perfect model for this task because we really want to do something about coding and SQL and things like this statements. So you want a model that is vast in codes. So I've decided to take the 14 billion parameter model because it definitely will have a larger context window. And the reason why I'm saying that the larger context window is really important, I'll show you that very soon in a jiffy. So in order to have this model Coin 2.5 coder, just come to this place, select the tag which is 14b and copy this command. Come to your terminal, and if you come to your terminal, as you can see, I ran this command already. It's Olama run this 14b, and immediately that is done, just type the word /by. In order to see the list of models that you have from Olama, you can type Olama. I'm going to do a video on this maybe later on. If you're interested, please subscribe right now and click the like button so that you don't miss any part of that tutorial. You can do Olama ls in this command prompt for Windows and terminal for MacBook, and this will give you a list of all the models that I've installed on this machine. So you see that's the latest one that I just installed, the Coin 2.5 14 billion parameters model. It's 9 gig in storage and it has a very large context window. So after doing that, now let's go back to our code, and there are a few things that we need to import. I'll be using LangChain here. The people at LangChain are just so awesome. They've provided us very good APIs to do this task. So here are just a few imports. I'm importing the PyProd root. I'm using this here method. From LangChain, I get create SQL query chain. From the LangChain community, I also get the query SQL database tool. Oh, I have this twice. Okay, let's take this one out. I also installed MySQL, and if you don't know how to do all this, you can simply go to your terminal or command prompt. In your case, make sure that you have Python first of all. That's a requirement. A big requirement to do this is to have Python. And here you just come to do pip install, and you specify the package that you want to install. In this case is MySQL, like so. If you do that, it will install. I've installed it already, so there's no need to do that right now. All these are still from LangChain. From operator, I get the item getter. Just a few things that I've imported. So those are just the imports. Okay. Now the next thing, I've created some helper functions here to extract the SQL query from the LLM, and I'll show you why I did this in a while. I also created a class which is called validated query SQL database tool. It inherits from the query SQL database tool class from LangChain community. And what I'm doing there is once this SQL query is valid, then I run it on the DB itself. This is with MySQL, like I've said. So I specify my username as expected and password. This is my username and password for my for my MySQL server right now. The host is localhost and the database is the one you saw from the workbench I showed you, this Honor World database. So in order to get a DB instance, we do SQL database from URI and we pass the URI. In this case, this MySQL is helping us to make the connection to MySQL via Python. We pass the username, the password, the host, and the DB. So after doing that, now we can check to see if our connection was properly made, we can check the list of the tables that we already have. And our friends at LangChain, they provide us a function to do that, an API to do that. It's called get usable table names. And if we do this, if we run this, then we get those three tables: transactions, users, wallets. And this is the part I was talking about, that in many other videos that I've seen online, people just talk to one single table, like they interact with natural language on one single table. But this, we are going to be dealing with multiple tables, which is, in this case, we have three tables. So now let's test our Olama model and see if it's working. We have this, like I said, Coin 2.5 coda, 14 billion parameter model, and we just get Olama LLM interface from LangChain again, and then we pass the model name which was specified. And if we try just an example here to see what the response is, we call this method called invoke on this LLM that has been created instance, and we just can say what is code. And now let's see what we get. So hopefully our connection is made properly. If Olama is working, then we should get a response very soon. It will take some time, of course, because this is a 14 billion parameter and you need to have the right computational power to run this kind of model. It's a fairly large model, so we give it some time and we will get some results. And here we have it. So it doesn't stream, it just gives the answer directly, and that's just a response from the model. Okay, so we are sure now that the model is working. It kind of lists Python as the first language and Java, JavaScript. Okay, whatever, that's not what we are interested in. This is just to see that our model is working. So now the first thing we do is to create a chain. This chain establishes a connection on the LLM and the DB. So LangChain, the guys at LangChain, very wonderful guys. So we create a chain this way, and now we can specify what the user question would be, just like we asked the LLM what is code. So now we want to ask it, our LLM, a question. Please enter your question. So I specified an input here, and the reason why I'm adding this text to append, provide only the SQL statement. This is part of the prompt that I'll be sending. The reason why I'm doing this is that I discovered that this Qwen 2.5 model will give you the SQL statements and a bunch of other things, like explanation to the SQL statements and whatnot, things that are not really necessary because it's just so smart. So I just ask it for the SQL statements alone. So I append that to the user question, and when we run this, we get this prompt. We get this prompt like that, and I can say, how many users do we have? Do we have a question? And now we expect some response. So this is fairly easy because we are only talking to one table right now. I mean, we know that we are talking to multiple tables, but the question is related to just one table because we're asking just about users. So it can easily just go into the DB and look at the number of users and just tell you it's 3 users or 4 users or whatever. And so this is the kind of result that we get from the LLM. That's the results from the chain.invoke. So we need only this select statement, for example. We don't need all this one because if we run this on the DB, it's going to fail because of all these backticks and all this extra string. So first, what we do is to clean this data, and that's where this extract SQL query function comes to play. And what I do here is that I get the response, which is that response you saw, and I replace all the extra string thing with an empty space. And that's it. And I return back that clean SQL statement. So the SQL statement in this case would just be select count star as user count from users. So eventually when we run this command, it's already cleaned. We will get 3. And this is actually the right result on the DB, because if we look at the number of users on the DB once again, we see that there are only 3 users on the database. We've actually chatted with our DB in natural language. That's the first aspect. Now the second aspect is this way called query SQL database tool. So we can add this to the chain, and the way we do that is, of course, again, to create the SQL chain just like we did before. And this time around, I'm adding this class validated SQL database tool to clean the data for me before running it. So let's go back to what this is doing. Here's the same thing we're doing there. We extract the response from the LLM and we get the SQL query. The SQL query in this case is the clean SQL query. And if there is no SQL query, we return no valid SQL query found in the response. If not, then we do a db.run SQL query. So we just simply run that query. This method called run has been written for this class. So we're only extending this method called run to run the query. So that's about it. And we can get that directly. And as you can see, that's what we're doing here. We validate, and to create a chain, we can combine the clean SQL statement with the execution tool. So write query with pipe and execute query. So write query and execute query, we combine it together, and eventually, of course, with our text to append, we do that and we get the same result. Okay, now another way is to answer the question in a user-friendly manner. So I give a prompt and say, given the user prompt corresponding to this, structure it in this way: question, user query, SQL results, and answer. So question will be the user question, query will be the query that the LLM will generate, and the result will be the friendly manner result, the result of the query, of course. For example, in this case 3, and the answer would then be the friendly answer to the question. So if we run that and we ask the same question, we will get, of course, the SQL statement, just like that. That's another way to do it. You can make your prompt by yourself from the prompt template. Something I forgot to say was here. LangChain already gave prompts, because you might be wondering how the LLM is able to know the context of the entire database in terms of the schema, the table names, and the values inside, the data inside, and things like this. If I comment this and just run this for you, this is the prompt that is passed from LangChain. They've already put this in the code to help us do this. It says you are MySQL expert. Given an input question, first create a syntactically correct MySQL query, then look at the results of the query and run the answer to the input question, and all that, and then look at this. Only use the following tables. So the table info here has been provided to the LLM. The table info is basically the schema. We know that we can get the schema from the tables, from the information schema table. We can get all the schema of tables. So that information is given to the LLM, and the format to respond is this way. How does LangChain know that we are using MySQL? We come back here. If you come to the top, you would see that if I print, remember that we created the DB instance, which is from the class SQL database. This SQL database class, don't forget again, is from LangChain here at the top, communities. So since we have this DB instance, it knows that the dialect could be MySQL, could be Postgres, it could be SQLite, and so on and so forth. So that's how it knows. I assume that they do some kind of check for the dialect, and if it's MySQL, then they use this prompt. And if it's another server, DB server, then they use a different prompt, but it will be mostly similar because the LLM needs to know how to create syntactically correct MySQL query. So that's the prompt from LangChain that I've shown you. Now the last part of it is here, using agents. This is the most interesting part. Again, we create SQL agents. Now this time around, not chain, but agents. And the agents have many parameters to be passed. First, you pass the LLM and you pass the DB. This verbose true here is to output anything as it's generating, just to see the process of generating the response. The handling passing error we set to true here, so that if there's any error in the SQL statement, it can put that error back again into the prompt and try again, and the LLM will try again to get the right SQL statement. So here is a little bit more complex question. I said, what is the total balance in the wallet? Which user, give me their first name and the last name, has the highest amount of money in their wallet? Okay, let's go to the wallet first of all, and we'll see. So here, the highest amount of balance in the wallet is $1,200, and that user is user 2. User 2 has $1,200 in their wallet. And who is user 2? Let's go to the users table. User 2 is Jane Smith. So Jane Smith has 1,200 USD in our wallet. Now let's see what the LLM would give us. So if we run this, I'm not going to run it right now because it will take some time. I ran it already. So this is the essence of this verbose true. You definitely see all the actions that the LLM is taking for you to know what it's doing. So first, it looks at all the tables. Those are the 3 tables. And it says, I need to find out which user has the highest amount of money in their wallet. This is very interesting. I mean, the LLM is just simply talking to itself. Next, I'll check the schema of the relevant tables, wallet and user. So it knows that from the list of tables that we have, it knows that it needs to use these 2 based on the question. So what does it do? It will then go to those tables. And since it already has the table schema, remember from that table info, it has the table schema. LangChain did this already for us. So it will create the schema, pull out 3, actually it pulls out 5, because from the prompt it says here, unless the user specifies in the question a specific number of examples to obtain, query for at the most 5 results using the limit clause as per MySQL. So the limit is 5. It should normally pull 5 results, but we have just 3 in the DB, so definitely cannot pull more than that. It pulls the first 5 results just to see examples to use. And after doing that, it says the total balance in the wallet is $1,700.75, and that's true. If we go to the wallet again, we see 500 plus 1,002 is $1,700.75. So that is true. The user with the highest amount of money in their wallet is James Smith. We saw that already, with a balance of 1,200.75. So it actually joined the both of them together. It didn't show the SQL statement in this case, but it did that under the hood. It got the SQL statements correct and did the join on the 2 tables, the wallet table and the users table, and gave us the result. So it finished its chain, and here is the output, which is what you've seen. The total balance in the wallet is that. The user with the highest amount of money in their wallet is Jane Smith with the balance of this. Just one more example. I'm making a query to say how many transactions have been made so far. And what transaction what transaction has the highest amount? So again, it goes into action. It says I will check the schema of the transaction table to understand the structure. It does that in this time around because we really don't need any joins. We're talking about only transactions. It's able to do that and it got the answer right. The total number of transactions made so far is 3, of course, because that's what we see from the table. If we check again, we know that the total number is in fact 4, but not 3. So it got this wrong. Total number of transactions made so far is 3. The transaction with the highest amount is the credit transaction of 300, which is a salary deposit. So let's check. The highest amount here is 300, which is correct. It's a salary deposit, which is also correct. Okay, that's correct. All right. And that's it's also a credit. Okay, so it got that right. It says it's a credit transaction of this. So it actually got 75% correct. The total number of transactions made so far is 4 actually in the DB. It's 4. I don't know why it said 3. So now you can see that it's very possible. Of course, there are limitations. It needs to get the SQL statements correctly, but I've shown you multiple ways to do that. Now you can use agents, or you can use the query DB database tool. If you don't need a friendly answer and you just want the result itself that you want to use later in another process, then you can use this method. But if you want the result in a friendly manner, like in natural language output format, then you go with the agent tool. I hope that helps someone out there. If this video gives you value, make sure that you click the like button. More of this will be coming shortly on this channel, and make sure you subscribe not to miss it. Until next time, I don't want to bore you with too long stories. See you. Bye.